Ground control approaching touchdown point.
Roger that. Easy now. Easy. Clear left side.
Bridge, this is the deck. ROV systems are green and secure. We are approaching the target location.
Tension levels are stable at 40 meters.
Copy that. Continue descent.
ROV-1, verify clearance on the trailing edge.
Affirmative. ROV-2, proceed with tensioning.
Watch your tension on the main cable. We're getting close to max load.
Copy that. Easing off the hydraulics now. Keep it coming up slow. Almost there. Starboard straps secured and tightened. Confirmed. Port side secure. All points documented.
Gate is secure, convoy approaching the hangar.
Roger that. Keep the perimeter clear.
Convoy 3 proceeding to Zone Charlie. Clear right side.
Affirmative. Clear right. Hold for alignment.
Lowering suspension point 2. Maintain current vector.
Copy that. Vector stable. Continuing descent.
The stress fractures along the fuselage are extensive.
And the corrosion suggests long-term fatigue, not just impact. We need more samples from this section.
Perimeter lights stable. Zone 3, activate.
Activation confirmed. All zones nominal. Every meter of surface tells part of the story. The violence.
Align the panel precisely with the marker. Verify the angle.
Angle verified. Panel secured. Ready to scan.
Control, this is Station 4. Calibration successful. Requesting final safety check before scan.
The structural integrity here is completely compromised.
Log that, especially the buckling near the center spar.
Documenting thermal deformation on the starboard fuselage, significant stress cracks propagating from rivet holes R14 and R15, brittle failure noted here.
The airspeed indicator is frozen at 300 knots.
Confirmed, the wiring here is completely severed, not just corroded.
The visible damage is only the beginning. The real secrets lie in what cannot be seen without specialized analysis.
Look at this trace pattern, just forward of the main spar.
Confirmed. Peak temperatures exceed 400 degrees right at the anomaly.
Mark this location for analysis. Mark this Zulu 5 as primary. The thermal stress indicators are clear right here.
Confirmed. Inputting coordinates now. The yellow tag goes at the secondary deformation point.
Wow, look at that. It's much worse than we thought. The corrosion has spread all the way through the linkages.
The door is open. Hold your position.
Running the sensor now. Atmosphere stable. All clear.
Switching to the torque wrench now. Need you to stabilize the housing. Got it. Maintaining angle 4.
This small space contains critical evidence about the flight's final moments. Evidence that must be carefully extracted and analyzed millimeter by millimeter.
The captain's control yoke exhibits clear signs of tension overload. Caliper reading.
The quick connect port is severely bent, and the rubber seal is missing. The demand regulator shows corrosion, but is functional.
Noted for the record, the fraying at AA01 confirms excessive force. The deformation at AO2 is significant.
Significant impact marks here and definite traces of green hydraulic fluid. Note the fingerprints on the casing.
Moving deeper into the center console, we're seeing extensive heat damage on the red and blue lines. Note the exposed conductor.
Investigators discovered evidence suggesting a fault existed before the crash, a manufacturing defect or progressive wear that went undetected.
The measurement here is 72 millimeters. The blueprint shows 45. That's a significant compression failure.
See the characteristics right here at the weld joint, both brittle and ductile.
Yes, and the penetrant clearly highlights the branching under the UV light.
Look closely at the corrosion here by the ducting.
Noted. We need detailed photos for the final report.
Documenting the failure mode on the left side. Bolts sheared cleanly here, while the seat across the aisle remains intact. Note the water staining.
Look at the deformation on the S4 stringer.
The laser scan confirms it. We have 50 to 100 millimeters deviation right here.
The distortion here is severe. It clearly failed during the impact sequence.
Agreed. The ultrasonic data supports a complete structural failure at this joint.
We're seeing a clear pattern of failure here. These attachments pulled completely out, leaving torn metal, while others show severe.
These concentrations here suggest forces inconsistent with the impact vector.
So pre-existing conditions then.
Every impact sign tells a story. Only by examining everything together can investigators reconstruct the scene.
Look at this. The continuity check is negative, but there's definite arsing here. This wasn't post-crash.
I'm taking samples now, Mark. We have severe exfoliation on this rib. Let's see if the lab can determine the timeline. Recording observation 44. The borescope reveals severe kinking and blockage consistent with decompression stress.
The depth gauge reads 4.2 millimeters here. Note the bulging deformation near the rib. This suggests pre-existing stress.
Compartment 24B. Life vest shows severe water intrusion and mold. Tag is partially legible. Photographing the inflation mechanism now.
Base, this is Perez.
We have clear evidence of both fatigue and impact cracks radiating from this rivet. The sample is secure.
What viewers are seeing represents weeks or months of careful work compressed into scenes. That each finding...
The tearing here suggests an upward bend before separation. We need high detail on these rivets.
Already on it. The flash should help define the texture.
Transition point alpha 7, ductile to brittle.
Rib 7 Charlie, complete compression buckling, estimated 70% height reduction.
We have pre-existing fatigue fracture, and this changes everything. Look at the crack origin point.
When was the last D-check inspection?
Calculate the cycles to failure from this length. We need your metallurgy team on this immediately.
Maximum crush depth 42 centimeters, located at station 375, consistent with approximately 30-degree impact angle.
Pin diameter 8 millimeters, material specification 204 aluminum, shear strength approximately 400 megapascals, gives us failure load around 45 kilonewtons.
Serial number November 7, 32 Golf Kilo, total time 6,200 hours, last shop visit 14 months prior.
Fan blade 7 shows forward bending, consistent with rotational impact.
Wait, we have another fatigue fracture here. Show me.
This transforms the investigation. It's no longer just about the crash, but why the aircraft was operating with hidden structural damage. Was this a maintenance failure?
Exterior casing shows impact deformation, southeast quadrant, depth approximately 12 millimeters, no obvious breach detected. Internal cavity compromised, corrosion present on connectors, but memory modules appear physically intact. We're getting good data, extensive coverage. Final approach data is intact.
Outstanding work. Start preliminary analysis immediately.
Mayday, mayday, mayday.
We have lost both engines, requesting priority landing.
Here, autopilot disengagement. Here, first altitude alert triggered.
Note the gradual descent initiation, not consistent with immediate emergency.
When flight data indicates a high-speed impact, the physical wreckage shows corresponding damage patterns.
Particle count, ISO code 21/19/D, exceeds acceptable limits.
Significant contamination across multiple sample points.
Arc initiation point identified, wire bundle 7 alpha 3, insulation failure, propagation across approximately 80 centimeters affecting multiple critical circuits.
Extensive delamination. No external indication. No maintenance record of previous detection.
We have multiple pre-existing conditions. Wing spar fatigue cracking, engine mount fatigue cracking, hydraulic contamination.
Striation count suggests crack initiation approximately 24 months prior, growth rate consistent with nominal flight loading cycles, no material defects detected.
Look at the pattern on this stress fracture here.
Yes, it aligns perfectly with the engine separation data.
Significant fatigue cracking, aft pressure bulkhead, originating at repair termination point. Growth stage suggests intermediate development. The timelets. This aircraft, while appearing airworthy and properly maintained, was accumulating hidden damage across multiple systems.
There's a clear link here. The contamination analysis confirms the fluid pathway intersected the compromised circuit. We've used the scan data to reconstruct the wreckage. The color cutting shows the severity, and these annotations point...
This safety recommendation here, are we sure it aligns with the evidence?
Yes, the data supports the need for the altitude alert system modification.
We don't have evidence to support that specific requirement.
Yes, but that is supportable from our findings. We should refine the wording here. We need to look closely at the stress analysis around these bolt holes.
We balance the design against weight constraints, but perhaps new materials offer a solution now.
The fatigue crack evidence is fully documented here.
Verified. I'm adding the supplemental images now.
And the engine mount data aligns perfectly with the preliminary findings.
These hidden conditions made the aircraft vulnerable.
When did the fatigue cracking begin, and why wasn't it detected earlier?
That's...
It was a tough one, but we got the truth out.
The aerodynamics puzzle was something else. Glad we solved it.
We honored them by learning everything we could.
The fatigue cracking analysis confirms the need for immediate action.
We must issue the airworthiness directive within 72 hours.
I'll finalize the maintenance standards update. The stress concentration here at the bolt hole is significantly reduced in the new design.
Yes, the FEA models confirm the load is distributed much better now.
I'm getting a strong return signal at the stringer.
Yes, the eddy current shows a clear crack indication. We're grounding this one.
Aviation safety improved through accumulation of knowledge from every accident investigation. Each investigation identifies The investigation process is a crucial part of the continuous aviation safety improvement cycle.
Flight 4556, wind 290 at 5, runway utilized, cleared for takeoff.
Roger that. Cleared for takeoff, runway utilized. Checklist complete, ready for departure.
Every piece of wreckage tells a story. Every fracture, every deformation, every hidden crack carries information.
The most important safety work often happens where cameras never go. In investigation facilities, in laboratories.